Stanford University.
All right, welcome to lecture number 13, Stanford CS 193P, fall of 2017 and 18. So we have a very quick demo today. I've actually kind of compressed it because I really need to get to the slides, very important topic, which is persistence. And so let me just dive right into that demo, and then we'll get to persistence right after that. So the demo here is I'm going to take our emoji art and add a little way to make a text field appear up in our little collection view that slides around, so we can add more emoji to that little sliding thing. So how are we going to do that? Well, to make this go quicker, here's our emoji as we left it off last time, but I've made a couple of little changes here. I've added two collection view cells. You see them right here, this one with a plus button, this is just a UI button right here, and then this one has got a UI text field. That's what this little, I don't know if you can see the light gray in there, but this is a text field inside here. That's the only thing that's in these new cells, and each of these cells, of course, I gave it an identifier. This one's called an add emoji button cell, and this one's called a emoji input cell. This cell is just a standard UI collection view cell. So if I look at it right here, you can see that its class is just UI collection view cell. But this one is a special text field collection view cell, okay, a subclass of collection view cell that handles this text field a little bit. And so we're going to go take a look at the code from that and actually add a little bit of extra code to that, because I want to show you kind of a just a kind of a tricky way to do things that's not tricky, but it's a really valuable way that's a little bit advanced, so I want you to make sure you learn that. All right, so I have these two new cells. Let's take a look at this code for the text field collection view cell. That is right here. It's a very, very simple cell. It just has an outlet to that text field you saw right there. Now notice when my outlet is set, I immediately set that outlet's delegate to be myself, and I'm a UITextField delegate. Okay, remember the slides from last time? And so I only implemented one delegate method here, which is textfield should return, and what it does is when you press the return key on the keyboard, it resigns first responder, which means it stops using the keyboard and the keyboard disappears. So if you don't do this little thing right here, then when you press return in the keyboard stays up, okay, and the cursor keeps blinking. Here it causes it to go away, and we're going to add another delegate method here in a second. Okay, so now, okay, remember that I have these two cells right here, right, the emoji button one and then the input cell right there. So now let's go back to our Emoji Art controller code and look how I dealt with this, how I put this in the UI. Well, first of all, that little plus button, it uses target action to send this message to my controller. Now notice it's sending it directly to the controller. If I had multiple of those plus buttons, they'd all be sending this message. But luckily I only have one, so this is perfectly fine. Remember that a lot of times if we have something in a collection view or table view and it's sending target action, we have it send it to a custom cell, right? Because we want each one to receive its special thing. But here you can actually have things send it to the controller. Now all of this, that plus button does is it turns this adding emoji on, okay, because we're in the process of adding emoji after you press that button, and then it reloads section 0. Now I have decided that I'm going to put that plus button and the text field thing in a different section from all the rest. Okay, remember collection views like table views, they have sections. So I'm going to have section 0 is going to be the plus button or the text field, depending on whether I'm adding emoji at the time, and then section 1 is going to be all my emoji as I'm used to it today. So how do we implement that? Well, we have to say we have two sections now instead of just one section. And when we get the number of items in a section here, we have to look at the section and see if it's section 0, then we have 1, either the plus button or the text field, or we have the number of emojis if it's our the old thing we used to have, whereas all those emojis going across. Okay? Then we have to change our cell for item at. This is this thing that gets a cell for a given thing to look at the section as well. So this is what this code used to look like, and I've just put it in an if the section is 1, then do what we were doing before. Otherwise, if the section is 0, then if I'm adding emoji, I'm going to put that text field in there. And if I'm not adding emoji, I'm going to put the button in there. So the button and the text field are going to be exchanging places, right? You press the button, it's going to change and switch to the text field because I'm going to set this adding emoji to true, and then I'm going to reload my section. That's going to cause this all to get called again, and it's going to switch back and forth. Okay? So I'm going to have to put some code in here, okay, when I switch to the text field to get the text out, and we're going to talk about that. But before that, let me show you a couple other things I did. One is I want the text field when it's there to be very wide. I don't want it to be tiny like all the other cells. I want it to be a wide cell. So I overrode this method here, a collection view layout method called size for item at index path. Okay, and you return a size for an item at that path. Well, if I'm adding emoji and we're talking about section 0, then I'm going for wide buttons. Otherwise, I'm doing the standard size I had before. And yes, these are blue numbers. They shouldn't be here. I should be calculating this based on the size of the font that the user chose in the accessibility slider, all that, but we don't have time for all that, so I'm using blue numbers here, okay? And then another one I overrode here is will display cell. That's another cool little delegate method in collection view. This is called right before it displays a cell. And here what I do is if I'm displaying the input cell, that little text field one, I make it become the first responder. That way when the text field comes up, the keyboard comes up. See why I'm doing that? So will display cell, another fun collection view thing. Now I only had to do a couple of other small things, like I disable dragging here if we're editing the emoji. If we're typing a new emoji, I don't let the dragging happen because it kind of just messes things up to try and be swapping things around at the same time that we're adding stuff. So I took that out of there. I also don't allow dropping. Where's my drop code here? Drop proposal, where's that? I can't find anything in here. Oh, here it is. So I don't allow, when you're repositioning the collection items, right, the little emojis, I don't allow putting it into section 0. Okay, that's where the plus button is. I don't want to drop smiley face or the bike into where the plus button is, that section. So I just say here that if the index path is section 1, then I'll do this thing where I'll, copy or move the emoji. Otherwise, I'm going to say the drop proposal is cancel, which means I can't drop there. Everyone cool with that? Okay, so that's all the code that I did. Now then let's run and see what this looks like here. Okay, here's our UI. So here's our thing that we have, so I can move things around. Okay, there's the plus button on the left. Okay, if I press that plus button, you see it gets replaced with the text field. Okay, and I can bring up my keyboard here and start, typing in some, I don't know, what do we got here? Some shoes and hats and stuff, typing these things in. Now, if I press the return key, my keyboard's going to go away because I've implemented that one text delegate method. See how it went away? But it's not adding the emoji because I have not put any code in here that actually takes what I typed in there and adds it to my scrolling list. Okay? So how am I going to do that? Well, that is the trick. Let's go take a look. We want to essentially, in our text field right here, when the text field resigns being first responder, right, when it stops showing the text field, then we want to put that in. So of course we're going to use this delegate method that I talked about called text field did end editing. Editing, there it is. And when this happens, I want to talk back to my collection view, basically, and say add the emoji that was in my text field. But how do I talk back to my collection view here? Okay, the collection view cells don't really have a pointer to their collection view. So that's an interesting problem to solve. And I'm actually going to solve it. A lot of people would solve it by trying to go find the collection view and talk to it or something like that. But it's actually a much simpler way to do this with closures. So I'm going to create a var, public var in this cell called resignation handler. Okay, and it's just going to be a closure, a function that takes no arguments and returns no arguments. In fact, I'm even going to make this an optional function so that it could be nil, doesn't have to be set. And then when text field did editing happens, I'm just going to call this thing, resignation handler. It might be nil, so I'll optional chain it and call it. So I'm just calling that function. Now, anyone who's interested when my text field resigns can just set this closure to something. And that's exactly what we're going to do back here in our controller, okay? Where we load up our cell, which is right here. If we're doing the emoji input cell, which is the thing with the text fill, I'm just going to say if I can let the input cell equal this cell as a text field collection cell, which is collection view cell, which is that cell that has that text field in it, then I'm going to set the input cell's resignation handler. Resignation handler. And I'm going to set it to be some closure that does what I want when that text field resigns first responder. Well, what do I want to do? I want to take the emoji out of it and put it into my list, of course. So let's just do that. I'm going to set my, well, first I'm going to say if I can let text equal the input cell's text field's text. Okay, so if I can get some text out of there, then I'm just going to have my emojis which remember that's my model right here. That's the thing that, oops, where is it? Shows all the emojis I have. I'm just going to add to that thing. I'm just going to say my emojis equals that text that was in the text field, and I'm going to map them, all the characters in there to be strings so that I have an array of strings. Right? And I'm going to add that to what's already there, so that's emojis. Just are the emojis we already have. And I'm even going to do a little trick here where I'm going to uniquify them. Uniquified. This is just a little thing that I put in that utilities thing, which just takes an array and makes sure all the items are unique. Okay, because I don't want to have multiple smiley faces, multiple bikes, whatever. Now, of course, I get this of, hey, you are using self implicitly here. You should put self dot. And every time you do that, you're going to pause and say, does this create a memory cycle? Or is this perhaps causing a multi-threaded issue? Well, there's no multi-threading issue problem here because we don't have a problem with cells being scrolled off and scrolled back on like you have in your homework. But there is a memory cycle here. Okay, you see how there's a memory cycle? Because self is the collection, is our self, this view controller, and we point to our collection view. Our collection view points to its cells, of course. Its cell points to this closure, and this closure points back to ourself. Okay, so it's going round and round. So we have to break this with weak self. Okay, and then make all our selves here be question mark. This is a self also. It can be self exclamation point because we won't get there if this is nil. So that's good, but there's actually another one in here. Sometimes just because it tells you about self doesn't mean there might not be other ones in there, and there is another one. It's this. This var is the input cell, and I'm using it inside this closure, which will capture it, and yet it is pointing back to the closure through its resignation handler. So this has to be broken as well. Now this one we can break with unowned because we know we would never be in this closure executing it if this were nil, okay? Because by definition we're executing its resignation handler. So we can use unowned in this case to do that. Okay, and what else do we need to do here? Well, we just need to stop saying that we are adding emoji because we're not, right? We've finished adding emoji here. And then we're going to have to ask our emoji collection view to reload data. Why do we need to reload data? Because we just added emoji to our model. And anytime you change the model, you need to update your table. So I'm going to reload and cause it to go back, look at my new model, call all those functions, all these functions right here. Okay, reload everything. It's also going to nicely reload section 0 and put the button back because I set this back to false. Okay, so let's see all this in action. Okay, here we go. So we got this. We can still scroll around. Normally we can reposition these things. It won't let us put it in section 0. Okay, that's good. We hit plus. It brings up the text field. It reloaded that section and put the text field because we're adding emoji right now. Can bring up my keyboard down here. Let's put some sea creatures in here. Okay, I'm just going to do that. Now I'm going to hit return, which is going to dismiss my keyboard because of that resign first responder I put in there. And since that's going to end editing, it's going to add these emoji to our list. See that? There they are at the beginning. Okay, and we can do the same thing here. Maybe I will add, I don't know, some farm animals here. Okay, and this time I'm not going to hit return. I'm actually going to dismiss my keyboard by pressing the thing in the lower right corner. You see that thing that says keyboard go away? Ready? Boom. And now it added those. Okay, so that's it. That's text field. Sorry we had to kind of rush that, but we got a lot of other stuff to cover. And I'll be posting this code so you can look at it in detail and see. I showed you all the changes we made. I just didn't type them all in as we went along. All right, back to the slides right here. Let's get to our main topic today, which is persistence. By persistence, I mean making things stick around, right? The user inputs some stuff, they create an Emoji Art document or something like that, and you, of course, want those things to stay around. You don't want them to disappear every time you run the app, which is the case in your homework and the case of Emoji Art right now, which is kind of useless. So there's a lot of ways to make things persistent, as you can see. So let's dive right in and talk about all of them. Now, some of them I'm only going to cover a little bit, and some of them I'm going to cover in depth. Okay? The first one here is user default. Now, this one is super duper simple. It's kind of like a dictionary that persists. Right? You put things in this dictionary with keys and values, and when you run your app the next time, oh, they're still there, okay? The only restriction on that, though, is that the only things you can put in this dictionary thing is property lists. Okay, now a property list is not a type or anything like that. It's just a concept. A property list is any combination, any data structure that is any combination of only array, dictionary, string, date, data, or a number, like float, int, or double. Okay, that's what we call a property list. And that's the only thing you can put in this little lightweight database called user defaults. All right, so what does the API look like to put things in there? Very simple. It's got two main methods here. Set, with a property list as the argument, for a key, okay, and then object for a key that returns a property list. The reason that's an any right there is that there's really no other type that would represent a property list, and this is an Objective-C API. But that any has to be a thing that is a property list. So it could be an int, it could be an array of strings, it could be a dictionary whose keys are strings and whose values are arrays of doubles. Those would all be considered property lists. Okay, but an array of CG float, not a property list, because a CG float is not a property list. Okay? All right. So how do you read and write this up? How do you access this? How do you call those methods? Well, we don't actually create a different user defaults thing. You can, but we don't usually do that. We instead use a shared one we get by saying user_defaults.standard. Standard is a static var in the user defaults class, and it returns this shared user defaults thing. And then we just call set on it to set values, and we can call object of type, or for key rather, to get things back. And so here's a bunch of examples of sets. Notice I can just set a float, because that's a property list. I can set an array of ints, that's a property list. I can also set nil, because it's an any question mark, and that means clear out any value for this key. Okay? And there's some convenience methods for getting things out, right? Because if you do object for key, what type are you going to get back? An any, which means you're going to have to use as to turn it into something. Well, to save you that, they have some methods in there like double for key, array for key, and those will return you that type. Okay? Now, for example, double for key, if the thing in there is not a double, it's just going to return 0. Because it's not double question mark, unfortunately, it's just double. And similarly, array for key, if the thing in there at that key is not an array, it's going to return nil, because that is an optional array. So these little things, these convenience functions try to help you, but they're only going to help you as much as they can. If you put the wrong types in there, obviously they can't do the right thing. Okay, when am I going to ever use this thing? This thing is really only for lightweight stuff like settings, preferences, that kind of stuff. You wouldn't store documents or any kind of serious user data in there with user defaults. Okay? Now, saving the database is auto-saved for you, so you really don't have to save it. But sometimes you want to, most notably when you're in debugging and you're hitting stop in the debugger all the time, sometimes you'll stop it before it gets a chance to save. So if you want to explicitly save, you can use this method synchronize, which will save it. It returns a bool whether it was successful, although I don't know what you're going to do if it wasn't successful. I guess try again in a little bit. But we usually don't look at the return value of this. We just say synchronize. So a lot of times people will put synchronize in there because they're doing the debugger and they're hitting stop all the time and oh, it didn't save them, and then they run it again. So you can feel free to do that if you want. It's pretty lightweight to do synchronize. All right, so that's the first one. The second way to make things persistent is called archiving. So the problem with user defaults, first of all, only small things. Second of all, has to be property lists. What if I have some data structure that I want to store that's big and or has things other than property lists in it? Okay? And to do that, I'm going to use archiving. Now, there's two mechanisms for archiving, an old way and a new for iOS 11 way. And of course, I'm going to talk in detail about the new for iOS 11 way because the old way obviously wasn't good enough. They came up with a new one in iOS 11. But they're very, very similar in some ways. It's just that the new way is a lot more automatic and a lot less code to write. Okay? So let's talk about these two ways. The old way is called NSKeyedArchiver. So NSKeyedArchiver is a protocol. And essentially, NSKeyedArchiver boils down to having every single object in the object graph that you want to save or whatever, to make persistent, implement these two things. A function called encode with a coder, so that NSKeyedArchiver kind of like is a dictionary thing. You can set values in there. And then init from coder. It's going to potentially give you that dictionary back, and you got to initialize the object. So it's very simple. You're just going to have encode sent to every single object in the object graph, and it's going to put itself in a big dictionary, and then when you want to bring it back to life, you start calling init with the coder, and they all have to initialize themselves. This is how storyboards are saved. So view controller, UI view, UI label, button, all of them implement both of these things, encode and init from coder. Okay, and somebody went to a painstaking amount of work to implement that for every possible thing that can be in a storyboard. It's amazing how much work that actually took. So that's great. You have this encoding and decoding ability. What do you do with it? Well, what you almost always do with it is you turn this thing into a data. Remember our friend data, bag of bits, that little struct? You turn it into a data, and then you can store a data in a file system, because as you're going to learn, that's how we interact with the file system. We store and read datas. Okay? So how do you take a big object graph where every single object in there implements these two things and turn it into a data? You do it with the class NSKeyedArchiver. So NSKeyedArchiver just takes an object that it and everything it points to implements these two things, and it gives you back a data that has taken the whole object graph and collected it up into a data. And similarly, if you give it back a data like that to NSKeyedArchiver, then it will turn it back into the objects by calling that init. Is everyone cool how we do that? This is a lot of work to make this mechanism work, because you've got to implement those two things for every single object in there. So let's talk about the new way, which is quite similar. It's called Codable. And Codable is a protocol. It's actually two protocols, decodable and encodable. And it works the same kind of way. Okay? You still have init and you still have an encode thing. The difference is Swift and the runtime and the foundation will implement those two methods for you almost all the time. Okay? You just kind of implements them for free, so you don't have to do anything. So as long as you are using kind of basic types in Swift, including all the things that you see on this slide, it just all magically works. Okay? So I'm going to show you both how we then take an object graph and turn it into a data with this mechanism, which is slightly different than the KeyedArchiver thing. And I'm also going to show you what it looks like to make something codable. Because to do this, it has to be codable, it has to implement codable. So let's look at those. First, let's look at how we turn it into a data. Here, instead of turning it into just an arbitrary blob of data that we don't know what it is, we actually encode it to a known format like JSON. Okay, everyone know what JSON is? It's essentially just like this text format for describing things on the internet, passing data around. And so JSON is a well-known format, and we can turn that big object graph into a description of it that is JSON, amazingly. And there's another encoder that can do this that does property list. Okay, so this whole thing I was telling you about user defaults, where everything's an array of strings or dates or numbers, you can also turn it into something like that. Okay, those are the two encoders that come with iOS. And how do you do this? Well, you just have your object that's of my type, some type that you define. That type has to be codable, and as long as it's codable and everything that it wants to be archived inside of it is codable, then you can say JSON data equals try to JSON encode that object. And it's going to give you back a data blob, and in that data blob is a JSON representation of your entire object graph. Okay, which is pretty incredible. Now notice this does throw. It's unlikely to throw when you're encoding, but it could possibly have something where I don't know why, but it couldn't encode it. It's possible it could throw. By the way, if you have a data blob that's JSON, you might want to look at it as a string. Okay, well, JSON is always encoded as UTF-8. That's the string encoding it uses. So you can always just take a data blob, like JSON data from that previous line there, and create a string with it. And all that string needs to know is what's the encoding. You say it's .UTF-8, which is Unicode 8-bit encoding. All right, now, what if you have a JSON representation of your whole object graph and you want to create the object graph out of it? Well, you just use a JSON decoder and say decode, and all you have to do here is specify the class or struct of the top level thing in that JSON represented by that JSON, and give it the JSON data blob, and it will decode it. Now, this also throws, and this is more likely to throw. Maybe your JSON data is corrupted or it's malformed or something like that. And it's quite possible to make this all work where you're using some standard JSON from some website out there and you're converting it to objects in your code, okay, where you make it do a one-to-one mapping. And so maybe the website you went to had an error and they generated bad JSON or something. So this could throw here. And we'll talk a little bit about that in a second, what to do with that thing throwing. Notice that JSON is the opposite of strongly typed, okay? Like a date in JSON is just a string in some format, right? There's no such concept as a date type in JSON. So this decoder is quite configurable, so you can specify things like what is the strategy to decode what should be a date. In other words, what format are dates stored in this JSON file. So you can specify those kind of things to configure the decoder to be able to figure out this JSON representation. All right? Now, I talked about throwing errors. Here, for example, I'm catching a error that was thrown by this decoder. And the reason I'm showing this actually is not because you're going to do this. You're unlikely to actually catch these decoding errors and do anything about them, unless maybe you're debugging your own JSON format and you want to see where you made a mistake or something. But I wanted to show you here what it looks like to catch an error that is thrown that's an enum. Because remember that anything can be thrown. You can throw any kind of thing as an error. All it has to do is implement the protocol error, which is really nothing. So you can throw anything. So a lot of times things will throw an enum. And when they throw the enum, you can do the same thing we do with switch, which is to grab the associated values out. So you see how that really works great for errors, right? So you're catching the key not found error, and you're grabbing the associated value, which is one of which is the key that was not found. Okay, so this is a common thing to do, is to throw an enum, and then in your catch, you just catch the cases, and you're allowed to do this same kind of grab the associated value as you can do with switch. Okay. All right, so let's look at an example of making something be codable. So I've got my struct myType here, and it's got a date in it, a string, and then it's got some other var, which is some other type not shown here. And to make it codable, all I have to do is say :codable. Okay? If I say that it's codable, then it is codable, unless it or something inside of it can't be coded automatically by Swift. So it's not one of those things I showed you on the first slide there. So here, date is definitely codable, string is codable, and presumably some other type has made itself codable as well. And so this thing is now codable. And that's all I have to do. Okay, a lot easier than implementing init and encode for every single object in there. We just say it's codable, and it is. And the JSON that would be generated from using that JSON encoder would look something like this, right? Some date, which is the same name as the var, colon, and then the date in some encoding strategy that we decide, and then some string, and a colon hello, and then other, and then a colon, and then whatever some other types JSON looks like would be embedded in there, you see? And then, so it can be recursively going down. Okay? Now, we might not want the JSON to look exactly like this. So can we tune this? Yeah, we can. Look at this. In JSON, for example, the keys usually don't have camel case, you know, like some capital D data like we do for our variables. Usually the keys are, the words are separated with underbar, like some underbar date. So we can easily change the keys that are generated when we use that JSON encoder by adding a private enum called coding keys, which is a string type enum, and it has to implement the protocol coding key. And all it does is has a case, it's an enum, right? It has a case for every var that we want encoded. So if we have a var we don't want encoded, just don't put that case there. And if you have a var that you do want encoded, but you want to change the key, just say equals the key you want. So here I've said case some date equals some underbar date. So now in the JSON, it's going to say some underbar date equals instead of some date. And notice that I didn't put some string case in there at all. So some string is not even going to be put in the JSON. Okay? So this is a really cool, simple way to customize the JSON that you generate from your type. Now, I'm not even going to really talk about this, but you can implement init from decoder, okay? The thing that actually, you know, pulls the thing out of the JSON. If you wanted to do some validation or some kind of complicated thing, or if, for example, you have a type that Swift can't encode, okay, some new type that you invented that's not made up of other types that Swift can encode, and you want to do it, you can do it. I just put this here as kind of so you can look at it later to see how you do it. There's a container in the decoder, and you get it, and it's got keys and values. It looks like a dictionary. It's not that hard. One thing is when you're decoding a class, you have to be careful to call super init, right? Because you're decoding, you have to implement init, so you've got to call super init. But don't call super init with the same decoder that was sent to you. The decoder was sent to you is for decoding your vars. You want to send this thing from the container called super decoder. That's the decoder of your superclass's vars. Okay? And then, of course, you could also implement encoding to encode random types that aren't part of the Swift thing. Again, I'm not going to go over this. You won't have to do any of this for your homework, of course. But for your final project, at least you know this can be done, is to implement encode and init yourself. All right, so that's it for archiving. Archiving, the whole point is we take some object graph of Swift stuff and we turn it into a data. And that data is either going to be JSON or property list format. Okay, so we have a data. Now we want to store that data in the file system. Okay, we want to put it in a file, just a normal file. Remember that iOS is Unix, and so we have a Unix file system underneath, of course. And it starts at / like any other user Unix file system. And all we need to do to store our data blob is just write it to a file. Okay, so how do we access this Unix file system in iOS? Well, the most important thing to understand is that the only part of the Unix file system you can access is your sandbox. Okay? Your sandbox is this little enclosed space. It's the only place you can write. You can't write into any system files anywhere. You can't write into any other app's information. You can only write in your sandbox. Why does iOS restrict you to a sandbox? Okay? Well, 3 main reasons. 1, security. Okay? Because we want to make sure that no other app can come along and break your app somehow. Okay, make it so that your app doesn't work. Privacy, you're collecting user information, whatever. You don't want other malicious apps to be looking in there and getting that information. And an underrated one is cleanup. Okay, you want to be able to clean up when the user says, I don't want this app anymore. Okay, if you have everything in a sandbox, you can delete that sandbox, and now everything that app has ever done is gone. Okay, so it's a cleanup part of it. So accessing the Unix file system is all about finding a starting point in this sandbox. Okay, and there's a few starting points that you can find. For example, there is your application directory in the sandbox. This has your executable, all your storyboards, JPEG files, your image assets, all those things. This part of your sandbox, you can get a Unix path to it, but it's completely not writable. You cannot write to any of this. You can only read it. If there was something you needed to write in there, like let's say you pass some initial database or something, you would have to copy it out into one of the other places in your sandbox and edit it from there. Another place in your sandbox, really important, is the documents directory. This is where you store stuff that the user perceives as their data in document form. And the reason it's important that it be user perceived as a document is because this directory, what's in there, is going to be visible in the Files app in iOS 11. Okay? I don't know if you all have seen iOS 11, played with it much. There's a new app in there, Files, and it shows you all the files in all the document directories of all the apps. Okay? So don't put things in the documents directory unless they're perceived as documents by the user. There's also application support. That's where you can put the stuff that the user creates that's not a document, because that's not going to show up in Files. And then there's other directories, about a dozen other ones. One of them, for example, is Caches directory. That's where you can put temporary stuff that could be deleted at any other time, at any time, and recreated. For example, in your homework for this week, I'm going to ask you to take your image galleries and cache those images, so that when people drag stuff in and they start scrolling around, instead of constantly going back and fetching those things all the time, you cache them in the file system. Well, you're going to want to put that in the caches directory because it won't count against your app in terms of disk space usage, and you can always just refetch it again if the cache gets blown away. Okay? All right, so you need to get paths to all these things. So how do you get a path to these special directories and then start building on it to build your own paths? Okay? Well, the first thing to understand is that all the access to the file system is going to happen through 2 classes, or two objects. They're not classes, they're structs. But one is File Manager, and the other one is URL. And you've already learned about URL because we've used URLs to the network resources, HTTP resources and things like that. Well, you can also have URLs to local resources, things on your disk. And a URL is essentially just a path, a Unix path to the file. So what you're going to do before you do anything is find one of these sandbox directories, because you've got to only write and read from those sandbox directories. So there's really 2 methods to get a sandbox URL, and I'm going to show you one of them here, which is I kind of prefer. I'll actually show the other one maybe in the demo. It's a file manager method, and the file manager is kind of like user defaults in that we use a shared one called default, although sometimes we would actually want to create a different file manager by saying file manager open parentheses close parentheses, right, just calling its initializer, which takes no argument, and I'll talk about when we'd want to do that a little bit later here. So this one is called URL for directory in domain mask, appropriate for create. Okay, so let's look at these arguments. The for directory is the sandbox directory you want, like the document directory, the caches directory, the application support directory. Okay, that's there, and it's specified via an enum here, and I'll show you some examples of what they are at the bottom. You can obviously go look it up in the documentation, what's available there. In domain mask is always .user domain mask on iOS because we have the sandbox and we can only look in the sandbox. On Mac OS, it could be a shared network domain, it could be the system's shared domain, etc. But on iOS, it's always user domain mask right there. Appropriate for, just you're always going to set that to nil. That's basically if you're going to replace a file, you want to specify the URL of what you're going to replace so you can make sure it's on the same volume as the URL you're getting. Again, kind of not meaningful in iOS most of the time, so that's usually just nil. And then create is an important one. That says whether you're going to create that sandbox, special sandbox directory, because not all of them exist when your app is created. Like application support does not exist, so you have to make sure you say create true right there. It doesn't hurt to say create true. I think document directory actually is already created for you, but can't hurt. So this is how you get a URL. You see the return value is a URL into the sandbox. Now that you have a URL in the sandbox, now you can start writing files. And the way you do that is by using the URL method, appending path component, so adds a directory or the name of a file onto the end of that URL. You can even add file extensions. It's perfectly legal, by the way, to say appending path component foo.jpg. You don't have to do the extension with a separate call there. But anyway, you're going to use that to build a URL that extends past the sandbox box, and it can have directories and stuff. You can, once you have URL, you can find out about things like, is it a file URL or is it an HTTP URL? You can get things like the write date. Is this a directory? How big is this file? From this method, resource values in URL. And resource values for keys takes a bunch of keys, like file size and stuff like that, and goes and looks it up in the file system and returns a dictionary with those keys and the value it found. That's why the value is an any right there. It could be a number, it could be a string, things like that. Okay, so you can find out a lot about your files there. How do you read and write files? We do that with data. Okay, and you've already seen this actually. We used data to read a file off the internet with an HTTP URL. Of course, you can do that with a file URL as well. We did not use the options when we did it because we use default options, which you mostly will, but there are some read options you can go look at. And to write files, you're going to send this to data. Write to URL, and it also has options you can look at as well. So that is how we read and write to the file system. We have a data, probably one we got by archiving the thing to JSON or whatever with our archiver, and we just read and write it with these two methods from the file system. So you can see it's all about just getting the right URL, and it's easy to read and write. Okay? I'm going to talk a little bit more about File Manager. Okay, it can do a lot of other things besides just give you a URL of something in the sandbox. For example, it can tell you whether a file exists in the file system. It can move files, copy files, create directories, enumerate directories, delete files, all that stuff, all in File Manager. File Manager has probably 100 methods in it for doing all that. File Manager also has a delegate. Okay, and that delegate, almost all of the methods are should this. Should I allow opening this file? Okay, should I allow you to move this file? They're kind of should things. So a delegate can control whether the file manager is allowed to do things. That and the fact that File Manager is thread safe, but only within one instance of the file manager. So if you have a file manager on another thread besides the main thread, it's thread safe, but only if that file manager was created on that thread. And the file manager.default that I showed you before, that's the main thread one. So you don't want to use file manager default in any other thread but the main thread. Okay? And of course, if you're going to set a delegate on the file manager, you probably don't want to set the delegate of file manager.default. That's kind of a shared file manager everybody's using in the main thread. So you probably want to create a file manager in that case. Okay? Multiple file managers know how to not step on each other's toes. All right? So we've learned the simple little database, which was the user defaults thing, where we could store property lists for that's just for settings and stuff like that. Then we learned about how to do archiving, much more powerful. We can store other things, and Swift will mostly just do the code for us, but sometimes we can get involved if we want. and it generates data. Then we learned how to take those data with JSON or whatever in them and store them in the file system using File Manager and URL. Now I'm going to talk about the next persistence thing, which is core data. So core data is if you have a large amount of data and you need to search over it. In other words, you need a database. So core data is essentially a SQL database with an object-oriented API. So you interact with this database. It looks like Swift objects, but behind the scene, those Swift objects are actually in a database, a SQL database. Now, core data is very powerful and can actually have backends that are different than SQL, but for the most part, we use SQL backend for core data. Okay, so that's what core data is. It's very efficient. Okay, beautifully object-oriented. Now, I don't have time this quarter to talk about it, but luckily, I spent a whole week on it last quarter. So you can go and look on iTunes U and see 2 lectures on it. It hasn't really changed that much for iOS 11, so it'll all be good. This is a great not covered in lecture feature for your final project because I'm not really going to cover it in this lecture. I'm going to kind of give you an overview of it, but you can easily go back and watch my last lecture and boom, learn all about it and be ready to go. Okay, so all I'm going to do here is a brief overview of it if you want a detailed of core data, and it is a great feature to do for your final project, believe me. Go check that iTunes U. All right, so it's a way of having this object-oriented programming layer with the backend SQL. How do we do that? How do we match those 2 things up? Well, we actually have a tool in Xcode, which is a visual mapper. You build all your objects and all their vars essentially in this mapper, and the mapper is used to figure out how to do that mapping forward for you, and it just happens automatically. Okay, so if any of you who know about databases, databases have tables, they have rows in the tables that are records, they have columns which are the fields. That's still happening behind the scenes, but you don't see any of that when you're programming because you're using an object-oriented API. So this is what the visual mapper looks like, right? It's in Xcode here. And here I have a couple of objects here, a tweet and a Twitter user. Okay, and those are going to map to objects in my code and tables in the database. And then we've got the fields, like the tweet's got a created date, the unique identifier of the tweet, the text of the tweet. And it's even got a var, which is the tweeter, which points over to the Twitter user. And on the Twitter user side, it's got a var called tweets, which is going to point back, which is actually a set of tweet objects. Okay, so this mapping is being used by core data on both sides, on the object side to make all these things look like objects, and on the other side to build the tables and rows in the database. So let's look at what it kind of looks like to do this in code so you get an idea. Again, I'm not trying to teach you how to do core data here, just to kind of give you an idea what it looks like. The most important thing about core data to understand is that we access all of it from the code using an NS managed object context. So this context is key, and there's 2 ways to get this context. One, you know how when we created a project there was that little switch there that said use core data? You remember that? So you can flip that on, and then you'll get a method in your app delegate, which we haven't talked about, we'll talk about that next week, that is giving you the context. It's actually a var that gives you the context. So that's one way. Another way is to create a subclass, or to use a subclass of UI document, which I'm going to talk about later today, which will give you the context. And UI document is a way of abstracting a document. So that's a way of looking at your entire database as just like one big document. Okay? It could be a huge document because this database can be big. But those are the 2 ways to get a context. Once you have a context in your hand, now you can start doing all this access in the database looking like an object. And here's what this looks like. So here, for example, I'm creating a tweet, and the only argument to the initializer there is the context, which is basically the database to put it in. But then if I want to set the text of the tweet, I just say tweet.text. It looks just like Swift. Tweet.created equals a date. Okay? Yeah, I can even create Joe, a Twitter user, in the same context as the tweet, and say tweet.tweeter equals Joe. I can even go tweet.tweeter.name equals Joe Schmo. In other words, use Swift notation to go through objects that I'm linked to. So it really looks just exactly like Swift. Okay? And I can also delete objects by just asking the context to delete them. Changes that I made are actually auto-saved if I use that UI document approach to getting the context. But if I use the use core data switch to do it, then I have to save it. The only thing about the save is it can throw. As you can imagine, if I'm saving this stuff out to the SQL database, I could get SQL errors or some kind of file system full or things like that. So you have to catch the errors if I'm not going to do the UI document-based auto-saving. Okay? Now, how about searching for objects, tweets and Twitter users in there? So here I'm going to search for some Twitter users that have tweeted in the last 24 hours. So first, I asked the Twitter user class for a fetch request. You see the first line there where I'm saying Twitter user.fetch request. Then this fetch request, I set a predicate on it, see, NS predicate format. And predicate is a way of specifying the search you want, you know, in text. It's not quite like SQL, but it's very English-oriented. So here I want any tweets that were created after 24 hours ago, okay, because yesterday is a var I made on the previous line, which is time interval since now minus 24 hours. Okay, so I've described my search that way. I also can describe how I want the results sorted. Okay, here I'm going to sort them by the name of the Twitter user. Okay, and then I just ask the context, please go fetch those things that match that. And it gives me back an array of those things, as you might expect. And if nothing matches it, I'll get an empty array. If there was an error, like maybe my predicate had a syntax error, I said like any twoots dot created by, then this is going to throw. Okay, and I'll have to catch it and figure that out. But otherwise, it returns an array of the objects. So it's really easy to query the database too. And it's using SQL to do that search, so it's super efficient. And it's even large values coming back, it's efficient about that as well. I can't really talk about how it does that, but it's also very efficient, even if huge things are returned. And Core Data can do so much more. It has great support for multi-threading. It has a very close integration with UI table view. As you can imagine, you often might want the information from the database to appear in a table. You can even set it up so a table is always showing the result of a fetch request, even if the database changes from underneath. Just automatically updates the table. And you don't have to do anything in your code. Just say what fetch request you want associated with the table. It does lots of good databasey things like optimistic locking and rolling back changes. You can do undo, redo really easily with this with the Core Data. And so I can't cover any of that, but I just want to give you kind of an idea of what Core Data can do because it's a very powerful framework in iOS. So check out my last quarter's iTunes U to figure out how to do that. I do a full demo, the whole deal. All right, so next topic is also something I can't talk about this week, but I also did a week on this the quarter before that. So if you go back one more iTunes U, instead of Core Data that quarter, I did CloudKit. And instead of either of them this quarter, we're doing the document browser, okay? So every quarter, I like to spend a week on persistence, and I kind of do a different thing each quarter. This quarter, I'm doing document. 2 quarters ago, I did CloudKit. So what is CloudKit? CloudKit is a database also, in the same way that Core Data is, but it's not a SQL database. It's a very simple database. It just has kind of objects and the properties in those objects, and you can query on them, but they're simple queries, and relationships between things have to be pretty simple and straightforward. But what's incredible about it is it's on the network. So this is a network database. So Core Data, you could have your database file on the network, but when you start accessing it, it has to bring the file down to your local machine because it's a local SQL database thing. Whereas CloudKit, actually, when you make a request to search for something, it does it over the internet to iCloud and says, search that database and send the results back. So CloudKit's API is completely asynchronous, right? You make requests, and then you provide a closure, and it calls you back later when it's got the result. So this requires a certain thoughtfulness in programming when things can take a long time like that. Okay, you've already seen this a little bit with multi-threading in your homework, hopefully, but it's kind of amplified in CloudKit. Now, it's not bad. It just requires you to think in a certain way as you're programming. So the important components of CloudKit: you got record types. That's kind of like classes. You got fields. That's like a var in class. Record. That's like an instance of a class. A reference. That's like a pointer to another class. You got databases and zones inside databases. You got containers that contain databases. You got queries. That's like a fetch request a little bit in Core Data. It's actually quite similar to a fetch request in Core Data. And then you've got subscriptions, which are a fantastic feature. That's you make a query and you give it to the server and you say, anytime the database changes such that this query would change, send me a push notification. Okay, do you all know what a push, who knows what a push notification is? Heard about that? Okay, so not everyone, but most people. So push notification is just something that comes to your app, and it'll even wake your app up and say, well, some information has arrived. And that is one of the coolest, if not the coolest feature in CloudKit, is that you'll get notified when the database changes in a way that you care about. Those are called subscriptions. But you're going to see, I'm going to show you some code for CloudKit. It's not like core data in that it doesn't look as much just like Swift in the code. You've got more function calls and stuff. Now, to use CloudKit, you have to turn on iCloud, and you do this, like a lot of things you have to turn on, like push notifications and other things, in the capabilities section of your project settings. So you're going to go there to capabilities, and you're going to flip this switch for iCloud on, and then you're going to turn on this little CloudKit switch down here, and that's going to enable that capability for you to use CloudKit. If you don't turn this on, you won't be able to use it. And when you do that, there's going to be this little button down at the bottom called CloudKit Dashboard. This CloudKit Dashboard, let's press it and see what it looks like. It's going to go to this place on the web where it's going to show you your database schema. So all your record types and all the little fields in it. Not just that, but the actual data, okay, which is not that useful once you ship your app because you're going to have thousands of users generating so much data you can't even look at it. But in development, it's really great because you create a object and you can go look at it and make sure it got in there and it's got the right data or whatever. So this dashboard is how you kind of work on your schema. It's not quite like the core data schema editor thing, because in CloudKit, different than core data, it builds the schema as you go. As soon as if you say create an object of this name, it'll just go create it. Okay, it's going to do it on the fly. You don't have to go and pre-build your schema like you do in core data. Okay, that's what this is talking about, dynamic schema creation. And this only works during development. Obviously, once you ship it to your users, then it's not going to create classes and fields on the fly as you access them. But during development, it's really nice. It's really easy to just start writing code and have it start building the database that would match that code. All right, so here's what the code looks like. You're going to see it doesn't look quite as nice as core data. So you have to get a database. So usually you're going to use the public or private cloud database. Then to create a tweet, you see you're going to say CK record. CK is CloudKit. CK record with the name tweet, which would automatically add that table to the database if it didn't exist. Then you're going to say tweet sub quote text equals the text. And then to have a tweeter, you have to say CK record Twitter user and then say tweet sub tweeter equals CK reference to record tweeter with the action delete this thing if the thing it's in gets deleted. So you see it's more verbose and doesn't look like Swift to be doing all this stuff. And of course, things like saving are asynchronous, right? So here I want to save this tweet in the database. Well, I have to provide this closure, and it's going to call me back once it's finished or if there were an error. Okay? Now, this networking programming, always a lot of error handling. Okay? So if you guys haven't done networking programming, get used to it. There are 29 different errors in CloudKit error, okay? And not all of them can happen on every operation, but a lot of them can. For example, I've shown the error here, not authenticated, because since it's CloudKit, if the user's not logged into iCloud on their device, then it's not going to know who they are, so it's not going to work. So you can get that error. You can get network timeouts, all kinds of stuff, okay? So that's just a different way of programming. You have to kind of get used to it, this asynchronous programming. Here's what a query looks like, okay? This is the analog of the fetch request. You still use NSPredicate, okay? So like text contains some search string or whatever, but the predicates can't be quite as complicated as in core data. Okay? They have to be fairly straightforward predicates. But then you create a CK query, which is a CloudKit query, and then you say perform, and of course it's asynchronous, so you provide a closure and it calls you back with the results of doing that query. Okay, so that's what querying looks like. Again, pretty simple, but asynchronous and not as powerful as core data. Okay, standing queries of subscriptions. I can't really show you what that code looks like because I haven't taught you push notifications. Okay, push notifications are not that difficult. There's a whole framework for it called user notifications, but it doesn't make sense for me to show you what it looks like when I haven't taught you that. So we'll put that off till later. Maybe I'll try and show an example of a CloudKit push notification happening when we cover that. All right. Now, next topic. So this is the topic that I am going to spend this week on, okay, which is document-based apps. So this is persistence when the thing that you're persisting is perceived by the user as a document. For example, Emoji Art. Okay, I create a beautiful Emoji Art document, put my ghost and my bike in there, my bees, and then I want it to save like a document, and then the user is going to go create a different one with some other image and some other stuff in there, and then we'll say that's a different document. So you see how they view them as a document. Same thing with your image gallery homework. You have a gallery of images that you built, and then maybe you want to have a different gallery of images that are related in some other way. Those are perceived as documents, okay? So we're going to talk about a mechanism that iOS API has for storing things as a document that is fantastic, okay? It takes care of absolutely everything you want to do with a document, and you have to do hardly any work to make it work, okay? All you have to do is actually convert your model into a data and back, and that's it. And it manages absolutely everything else. So when I say it manages everything else, what do I mean? Well, opening, writing, reading, closing document files asynchronously is all handled by UI document. Now, why do I want my documents open, saved asynchronously? Why do I care? My documents aren't big. It's not going to take that much time to write them to the file system. Who cares? Okay, well, UI document supports saving your files in iCloud Drive, okay, on the network, and that could be slower. So if you had to write the code to save them to iCloud Drive, you'd be very sad indeed, because you'd have to do all that networking code to figure out, how did I get this thing over the network? Did it fail? Is the network? Whereas this way, you use UI document, you just say save, it'll just call you back when it's done. Okay, it's all asynchronous. It's awesome. Okay, it also will auto-save your document, and again, I told you one of the ways to get a context for your core data is to create a UI managed document, it's called, which is a subclass UI document for core data databases, and it will auto-save it. Well, the same thing happens for yours. Your documents can just be automatically saved. You don't even have to save them. And the most important thing about UI document is that it integrates with iOS 11's Files app, okay, and the document browser. And we're going to see, if we get to it today, which hopefully we will, what that means, because it means a lot. It's very powerful. Okay, so what do you need to do to make UI document work? You want to have UI document. Well, I'm going to assume you already have an MVC that displays your document, and that it has some var or vars that are its model, right? This is MVC. Of course, it's got a model. So like in Emoji Art, we don't have our model yet in Emoji Art, but imagine I had some var of type Emoji Art, which was the model for what I'm showing. And it would have the URL of the image, and it would have all the emoji and where they were and the size they were, right? That would be the model of the thing. So I'm going to assume I start there. So all you need to do to turn your app into working with UI document is to be able to convert that model to a data and convert from a data back to the model. Well, earlier in this lecture, didn't I just show you exactly how to do that with the archiver? Really easy. So you could use JSON format as the file format of your document and just use the archiving to turn your model back and forth between the data. And that's really all you have to do. The only other thing you might want to do is tell the UI document whenever your document changes, like if you drag a new emoji in or whatever, and then it'll autosave. Because you have to tell it that, otherwise it doesn't know when to autosave. But that's it. It's literally called one function, my document changed, and it'll figure it out from there. Okay, that's it. That's all you have to do to make UI document work. Really implement two methods, get and set my model as a data. So how do we do that? We subclass UI document, and we override two methods, the one that creates a data and one that gets our model from a data. Now, we're almost always going to want to add a var in our UI document subclass, which is the model. Okay, the model that we're going to be converting to and from a data. So here, if I had an Emoji Art document, subclassing UI document, I'm adding a var called Emoji Art, which is of type Emoji Art. That's presumably the type of the model that I have in my Emoji Art document. Okay? Now, there are other methods you can override in UI document that do some things. I'll even talk about one of them towards the end. But the main two things you want to do is the reading and writing of the data. And the only thing you have to do to create a UI document is specify the URL it's at. Okay? So the only initializer that exists for UI document, it takes one argument, as you can see it in yellow right there, file URL. And that is going to be the URL of the document. Now, I'm going to show you later that this URL might be given to you and might be an iCloud Drive. And you might not even care, okay? But you also could, of course, create a URL somewhere, presumably in the documents directory of your sandbox, and create your own document if you want. Okay? But actually in iOS 11, usually we let the Files app mechanism give us the URL. The user goes to where they want the file to be, and they say create document, and it gives us a URL, and we just call this to create our UI document. Okay, now once we've created our UI document, we're going to set that var that I defined at the top of the screen there. Okay, we're going to set that model in there, and then UI document's going to take it from there. It's going to read and write the file and everything. All right, so how about doing this conversion from Emoji Art to data and from data to Emoji Art? Okay, so here's the two methods. This is the one that converts your model into a data. It's called contents for type. Okay, it does throw. You could throw if you have a problem converting your Emoji Art to a data. You could throw, and I'll show you where that thing gets thrown to. And notice it returns an any. You would think that would return a data right there, but it returns an any because you can actually also represent your document as a directory full of files. That's called a file wrapper. Okay, but we're just going to talk about the data way of doing it. Okay, if you want to do the file wrapper way, you have to look up the documentation for a file wrapper. It's not that hard, but it's a little more complicated than just turning it into a data blob. And so how am I going to implement this method? Really easy. I'm going to use that archiving stuff and use a JSON encoder or something right here and create a data object. Okay, and I just return it. That's it. So this often is a one-liner, this contents for type. Now that type that you see right there, yeah, I already said you could throw there. So the type that's passed along there, that's a UTI, a universal type identifier. And I'm going to talk a little bit about what that is in a few slides. Okay, this is not a type like .jpeg. Okay, this is a type like public.json, which would be a JSON file, or public.image, it's an image file. That's the kind of thing that's going to be in that type name. Usually you don't care, because usually your UI document only opens one kind of file anyway, like an Emoji Art document, so you don't even care what that type is, but you might be a UI document that can be in different formats, and then maybe you care. All right, how about the other way around? You've got a data, okay, that's handed to you. You've got to turn it into your model. Okay, again, you're probably going to use that JSON decoder and take the data and turn it back into an Emoji Art. Okay, and again, it's got the types there, load from contents of type, that's UTI. This one throws as well. This one you're more likely to throw, okay, because here you're being given a JSON thing or a data blob, and you're turning into Emoji Art. It might be corrupted, it might not be in the right format, something's wrong with it, so you might throw here. Okay, and in fact, that's all you need to do is implement those two methods, and now you can use all the methods in UI document like open, which opens your document, and it's asynchronous, so you provide it a closure there, and it even tells you whether it successfully did it or not. And if it doesn't successfully open it, you're going to be looking at this thing called document state, and I'm going to talk about that in a second. Right? So that's how you open a document, and you do have to open your UI document before you can use it, of course, because UI document wants to go and get the file and get the data and stuff like that, call the method that converts into an Emoji Art or whatever. But you do have to open your file. Okay, you can save your file explicitly, or you can just do auto-saving. If you do auto-saving, this is the method you have to call to tell your UI document, I've changed. Okay, update change count .done. Another way, by the way, to do this is to use the undo manager of UI documents. Unfortunately, I don't have time to teach you about doing undo. Undo manager is a really cool little class where every time you do an operation like drag a new emoji in or resize it, you go to the undo manager and say, I just did this operation and here's a closure for how to undo it. Okay? And then it automatically does undo, redo, and just pulls those closures up so you can undo and then redo, go back and forth. And of course, if you use the UI Documents Undo Manager to do that, then it will know that the document has changed when you do these undo and redo things. Okay? So that's another way to do it, is to use the Undo Manager. If you want to explicitly save, there is a save. The save one is not like open. It actually has a couple of arguments here. The reason you have save to URL is for save as. Okay, because of course the document knows its own URL. That was specified in its initializer, the file URL. So save to URL allows you to save it off to another URL, right, save as. And then that for document save operation, unfortunately when you save, you have to know whether this is the initial document creation save or whether it's a subsequent save. Okay, you have to tell the system that. I'm not sure why it makes you do that versus it going out and figure out. I think it's just for flexibility because it can save into so many different kinds of containers. iCloud Drive, your local file system. It can even save into things like Box. Okay, so maybe some of them don't allow it to ask the question whether the file exists or not. I'm not exactly sure why it does that, but when you save, you do have to know whether you're creating it or not. When you're done with your document, you're going to want to close it. Of course, one of the big things this does is save it if it's got any outstanding changes. And again, if it fails closing it, you're going to have this document state thing. So what I keep saying, look at the document state if things fail. What is that about? Okay, well, let's look at the document state. The document state is a var in UI document. You can look at it and see how your document's doing. Here are some of the values. Normal, that means your document is ready to use. Okay, just do whatever you want with it. That's the normal state. There's also closed. That means either you haven't opened it or you tried to open it and it failed and it's still in the closed state. There's saving error, which is you tried to save it and it failed. There's also editing disabled. That is a method on UI document which is disable editing. And why would you ever want to disable editing? Well, for example, the core data document, UI managed document, it disables editing when it's doing some sort of a SQL operation to update the database. Now, it only happens for a microsecond that it's disabled. But essentially, when editing disabled is the state of your document, you just would not want to allow users to drag new emoji in or resize anything. Not really an issue in something like Emoji Art, where it's very simple, but it can be an issue in a core data or some other more complicated storage mechanism. Then there's the progress available state. That means you did open on a document and the document is huge and it's downloading it from iCloud or something. And this will tell you that progress, via the progress bar in UI document, will tell you how far along it is. And it'll stay in this state until it's fully downloaded. Then it'll move to open, or normal rather. And finally, there's in conflict, which is a very fascinating one. Since the document can be stored in a network container, it might get saved somewhere that had network access at the time and then start editing in another place that didn't have network access or vice versa, resulting in two versions of the app finally getting saved up to iCloud. And now you have two versions that might be conflicting. Okay, and that's what this is about. Now, you're not going to deal with this in your app. You're probably going to take the default behavior, which is it uses the one with the most recent file date, okay, whichever one was written most recently it uses. But if you want to resolve the difference, if you want to notice this and resolve it, you can use this NS file version static method here and get all the different versions and look at the differences of them and maybe offer the user some choices, whatever. That'd be up to you. But for things like Emoji Art, you're probably fine with just always taking the latest version, whichever one was saved latest. Okay, document state, this var, can also be observed in the same way that the keyboard observing can happen. Remember I told you there was a way you could like tell the system, hey, if the keyboard comes up, tell me about it, right? That's called a notification. Same thing here. You could say, hey, if my document state changes, tell me about it, and it would tell you that. I'm going to tell you how to do this next week when we talk about notifications, and I'll mention document state and keyboard and show you what a code looks like to watch your document state. Finally, I'm going to talk about a cool little extra method you can override in UI document to put a thumbnail image instead of your document's icon. Okay? By default, when you look at your documents in the Files app or whatever, they'll have icons, right? Whatever the file type icon, the JPEG file icon, whatever that is, or if you have an Emoji Art type file, which we're going to talk about on Wednesday, it would show that icon. But you can also say, when the user sees my file in the file system, actually use this thumbnail image of it as its icon. Okay, this is a really powerful way to make it easy for users to find which document they want. Because imagine Emoji Art, you do some nice art, and it makes a little thumbnail of it, so you can actually see the document before you open it in the file system. It's like the icon of the document. And to do that, all you have to do is override this UI document method called file attributes to write to URL for operation. This is normally just going to return a dictionary of the file attributes, like is this file hidden, things like that. But you can override it, get the super file attributes it would normally return, and then add this very special dictionary item called URL resource key.thumbnail dictionary key. And the value of it actually is another dictionary, with the key being thumbnail dictionary item NS thumbnail 1024 by 1024 size key. And the value is a UI image. Okay, so you add this to the dictionary if you have a UI image to be the thumbnail and return it. Now it says there NS thumbnail 1024 by 1024, but it actually can be any size. It seems to me that if the size gets too small, then it'll start using the icon for the file. So it can't be too small, and I'm not sure what too small is. Probably has something to do with how big the icon image is. Maybe if it gets smaller than the icon image. I'm really not sure how it chooses. But as long as the image is decent sized, and I don't know if there's a limit too big, but you probably wouldn't want to waste your time creating anything bigger than 1024 by 1024, because it's going to be a thumbnail. It's going to be small in the file, showing in the Files app or whatever. You could return it. So we'll do this in the demo on Wednesday as well. Okay, so there's some other things in UI document like localized name. It'll look at the URL and get the name at the end of the URL, things like that. You can find out if you have any unsaved changes currently. You can get the date the file was last saved. You can even do user activity, which is this thing where you start working on something on one device and then you go continue on another, and you'll be exactly where you were before. Okay, so we're out of time today. I did have one more topic which we'll start off Wednesday, which is the UI document browser view controller. Which is an awesome way to give a very powerful user interface for your user inside your own app to create files, move files, delete files, put them in folders, drag them from iCloud Drive to your local hard disk, all this stuff. You get this powerful UI, very little work on your part as long as you have a UI document-based app. So we'll start off Wednesday. I'll tell you about that, and then I'll dive into converting Emoji Art to be a UI document-based app that uses all this cool UI and all that stuff. Friday, no more sections, so there's no Friday section. Next week, I'll be talking about alerts, notifications, I mentioned that, application lifecycle, that app delegate thing, and some more about segues, okay, more segues that we haven't talked about as yet, so that's what I'll be doing next time. All right, I will see you then.
For more, please visit us at stanford.edu.